Hello, everyone. We're just going to wait a couple of minutes until we get some people some time to join, some more concurrent viewers. Just hold on. Okay, so I think we're going to start. Welcome, everyone, to our first event of 2021. It's a live one on YouTube. So we're still doing this live due to lockdown, but we're going to explore other more interactive online events and then eventually return to in-person ones. So thanks to those who are joining, and I think a vast majority of people seeing this will be seeing this after. And I'm going to now begin. So first of all, there's a Discord server managed by PyCon and it's hosting a couple of meetups in that Discord server itself. So we're all kind of together in a big Python South Africa Discord community. So you can join there. Go to the bottom, you'll see Gauteng Python User Group, and you're free to chat over there and stay in touch, ask questions after this, that is. And I hope to see you there. Next up is Slido. Slido is where we will be doing our Q&A. So please go to slido.com, and near the top of the page, you'll see an option to join a Slido Q&A, and it'll ask you for a number. That's the number. And if you want to go by a phone, then you can use a QR code. And now we are going to present Tim Brophy, adding full observability to your Django application in minutes.
Hi everyone, my name is Tim Brophy, as I'm sure Adam mentioned in the intro. I am a solutions architect working for Elastic, so that's the company behind Elasticsearch. I work in the Northern Europe and Middle East Africa team, and I cover mostly South Africa and Africa, and I'm very excited to present here tonight. I guess I'm a Python enthusiast. I wouldn't say I'm anything beyond an enthusiast, but I think it's a great language, and I'm just very grateful to be on your meetup. So just before we jump into the actual demo itself, which will be really about speaking about our observability solutions with Elastic, I'm going to go over a little bit of an introduction of both myself, really light-hearted, hopefully quite quick, and also an introduction to Elastic for those who are not familiar with Elastic as a other platform in general, or where we are today, and the things that we kind of power and what we do. So that being said, moving swiftly ahead, the topics tonight will really be just a quick intro, and then we'll look at Django and Elastic observability and how we can solve a whole bunch of problems by giving observability or visibility into your application performance and logs and metrics in one view to help you troubleshoot issues more effectively. So from my side, as I mentioned, I'm a solutions architect. I work in the Northern EMEA team, cover South Africa and the UK. I've got a background in software design and development many years ago, but I've worked with databases and application architectures and sort of cut my teeth there, then moved into system architecture and sort of around the advent of the cloud. Really focused on cloud architecture, and in recent years have been very focused, prior to joining Elastic, on running agile development teams. My contact details are basically those links over there. So you're more than welcome to email me at Elastic or connect with me on LinkedIn. A little bit about myself. I'd say my primary hobby would be running. I don't look anywhere near as happy as that when I am running. So my secondary hobby is nursing my injuries. And at the moment, my favorite movie is Scott Pilgrim versus the World. So just a little bit of background information to give some context to who I am. All right, so I haven't seen any kind of notes about bad audio or video coming through, so I think we're good to go. So I'll jump into Elastic, right? So Elastic is a search company, and I'm sure that there are people on the meetup or on the session that have used Elasticsearch to solve a search problem. So looking at content, adding search capabilities to go through loads and loads of content to find relevant results at speed, and leveraging the power of our ability to scale, which really is what we do. We power applications that are already based around search problems, so like Uber. So when you're looking for a ride, Elasticsearch is powering that experience. If you've traveled and you're in the States and you're looking for a restaurant, we are the sort of engine that drives Yelp. And we basically underpin a whole host of applications that you wouldn't know that Elastic is necessarily behind all of those. So Forbes recently called Elasticsearch the most important company that you've never heard of, because invariably most people living in a kind of digital environment, a digital world, are using Elasticsearch powered services in one way or another and not really being aware of it. The reason for this proliferation is obviously we are an open source project, began as an open source project, sorry. We've moved into more enterprise level offerings with paid support and paid for features, but you can still download our basic license platform at no cost. You can run it to power production applications. I mean, there's obviously the support is then on you, but there's a huge amount of functionality that comes with that. So, most of what I'm going to show you tonight, if not all, is available via basic. So it's basic is free. So really, it's we're still widely adopted due to that. As I've mentioned, we're fundamentally a search company, but we really focus on three elements, and this underpins everything that we've already built, and that is speed. So how do we get answers to questions as fast as possible? How do we not fall over when we start to talk about massive scale, so huge amounts of data? How do we scale horizontally? So Elasticsearch is a platform that clusters horizontally and scales completely natively without any additional kind of management overhead or tools. It's something we do sort of by design. The other very important facet is relevance, right? So it's pointless asking questions of the data, getting fast results, being able to search through millions and millions of records that have those search results be completely irrelevant. So we have a very strong relevance model and give you as developers, either if you're using our query DSL language, which is kind of the the developer interaction language that Elastic ships with, we give you a lot of tools to fine tune the relevance of your results based on factors like what is the actual purpose of the site that you're searching through in terms of content, what sort of products do you want to promote, etc., etc. So that being said, right, so as a basic platform, just to kind of level everyone up in terms of what we are, we're fundamentally a NoSQL document store. So we take JSON objects, we ingest them into our data store, and we index those objects. We take the fields, we take the values of those fields, and we put them in inverted indexes. We stem those words. It's basically a myriad of tokenizers and combinations of tokenizers and like analyzed fields that you can configure for your environment. And basically, we take those documents and those indexes and we shard them. So we split them up, and we always have a primary shard and a replica shard. So in an Elasticsearch cluster, which could be one node or could be 1,000 nodes, we take those shards and we distribute them equally across all of those nodes. So obviously in the case of one node, we can't take a primary and a replica shard and put them on separate nodes to ensure high availability. But everything from 3 nodes up is highly available and out of the box, and adding new nodes doesn't engage or doesn't take on or add any kind of complexity to your environment. You manage them as if they were basically a single cluster with a single management layer. So it's a very powerful, very scalable platform. And like I said, your cluster grows as your data needs grow. You don't have to worry about really like additional management overhead or complicated third-party tools or different models of ingesting data if you grow your clusters. Once you've got your pattern pretty much defined, you understand your use case well, you can just add additional nodes into your clusters as you take on more data. It gets even easier when you're using our cloud platform, but I'll talk about that when I go through the demo. So if we look at, I've spoken very much at a basic level about Elasticsearch and what Elasticsearch is about. What we've seen from the community is obviously I think some people might associate us with pure free text search. So how do I get results back based on text boxes with potentially misspelled words, type ahead functionality or suggestions, etc. So we've taken that kind of search requirement and we've bundled it into something called Elastic Enterprise Search, which is a turnkey way with a graphical interface to curate and refine your search experience. And that also is initially free with basic functionality. So you don't necessarily have to dive too much under the hood into Elasticsearch, into your index mapping and how we ingest fields and what we do with them. You can kind of just let the enterprise search solution take care of that for you, and you ask it questions, you pass it data, it gives you a JSON payload back, and you render that payload to your users on your application. That enterprise search sort of bundle also has an internal search engine called Workplace Search, which can look at your internal content like Jira, like OneDrive or O365, SharePoint Online, etc. Confluence, Google Drives, all those kinds of things. So you can kind of get a very modern search experience internally in your organization to look for documents, which typically in larger companies tend to be spread out over a myriad of services all over the place. Then we've seen the community sort of really start to use Elasticsearch definitely in the early days as well, for things like logging use cases. So the power of search on top of a log file generated by an application is really useful because you can start to look for errors and look for patterns and understand more about your logs. So you'll see that there's a box on the kind of bottom right called Logstash. So Logstash is an ETL tool, but really its first job, and the reason it was developed was to extract log file data, transform it, and load it into Elasticsearch. With the log files, it started to make a lot more sense that we would start to ingest metric information from platforms like Prometheus that might be capturing metrics, system metrics, application metrics, etc., and giving us percentages about CPU, RAM, and storage usage, and in a given time interval. So by adding logs and metrics together, you start to get a bigger picture of your application environment or your infrastructure at that point, because you basically can correlate these two things together. So we started to create a product or a solution set called observability, and that's really what we're going to focus on tonight when I jump into the demo. And what we've done is we've taken logs, metrics, and we've augmented that with application performance management as well. So how do we make use of distributed transaction tracing, look at spans within transactions, understand where is an application stalling, where is it maybe doing something like a recursive loop, a SQL loop anyways, like finding information looping further and causing issues that could be prevalent on the front end to the user. We've also recently, as of 7.10, which is our most recent release, we've introduced user experience monitoring as well. We have had it in the past. That's a RUM agent, which is based in JavaScript. We've had that in the past, but we've really strengthened what we can do there. It's not part of tonight's demo, but we do have a demo that's publicly available. I'll kind of navigate to it at the end. It's really powerful, gives you great insight into browser rendering times and things like that. So the point of observability is that you can see all of this information within a single application, cross kind of correlated between all of those data sources. Then we've sort of looked at that and gone, well, if we understand all this about the application and the environment, and I promise I'll skip my slides shortly. If we understand all that about the application and the infrastructure, surely that can lend itself to a security use case. So we built a SIM. We built a SIM on top of Elasticsearch, and that SIM can look at network traffic, observability data like host metrics, audit logs for user logs, etc. And it can build a picture of your application or your ecosystem security posture. We've now developed over 300 detection rules that when you deploy the Elastic SIM, when you start to ingest data, you can enable those rules even if you're not a security analyst. So with one license, because all of these things are not licensed separately. We have license levels like basic, gold, platinum, and enterprise, but we don't have an Elastic Enterprise Search license or an observability license or an Elastic Security license. When you are licensed on the platform, you get access to like all of these use case solutions. And it's only when you want to start like climbing up the stack in terms of service and support from us and some advanced features that you need to start paying. So it's really it's almost like a penalty-free model where, and I'll show you tonight, it's really easy to take your observability data. You don't have to really do anything, maybe collect an audit log from a machine, and you can turn that data into security data. And then the thing that I've added on here in the far right-hand corner, it's not an official portion of our marketing slides, is we still are very, very amenable and open and useful for specific use cases. There's amazing case studies from around the world about how Elasticsearch is solving business challenges. Most recently, one of our architects in the UK helped Deutsche Bank to actually monitor their trade settlement engine. So when they're buying stock on behalf of some of their investment banking clients, they need to like manage that business process through to completion. And they're using Elasticsearch to get full observability of what's actually going through, like how many systems are involved and how long does it take, and analyzing, getting more insights into that. We even get used for complicated use cases like mainframe offloads. There are two banks, Clydesdale in the UK and Rabobank in the Netherlands. Mainframes are expensive. Elasticsearch is not expensive. They take mainframe data, transactional data, and they put it on the Elasticsearch cluster so that they can query and learn information about their customers without needing to pay a huge amount of like MIPS transactions and things like that. So I'll move on. So on with the demo. So what are we going to do tonight, or what's really the heart of it? So we're working on Google Cloud. I'll have just got a very small VM on Google Cloud running. It's an Ubuntu VM. I've got a Django application that I've kind of pre-configured, and we'll be using Elastic Cloud. I just want to highlight this is not a demo, right? This is a demo. It's definitely not a demo. This is a demo, but it doesn't contain like best practice recommendations. I'm just going to do things very quickly, but the idea is to show you how you can just add data to an Elasticsearch cluster and start to get value from it. So please don't see this as a reference for just in free text put your secret tokens and things like that. So the environment is an Ubuntu server. If you do want to go to this URL on HTTP, that particular port, it should be sort of dead at the moment. It's not running. But if you want to click around when I do spin up the Django app and drive some traffic there, that'll be great. But it's an Ubuntu server. I'm running Python 3 and I'm running Django. I've got a bunch of additional things like crispy forms and different libraries to help with the general Django app. And then we'll use cloud.elastic.co. So that's the Elastic Cloud. I've created an Elasticsearch cluster. I've set up Kibana, or it's been set up for me, and our APM server has been set up for me as well. So those are the main kind of facets. This is just so you get a sense. I've the things that are kind of grayed out, I've done just because they are fairly repetitive, and I'm sure everyone here has done this on their daily lives 500 times. But I've just set the site up. The Ubuntu VM doesn't ship with pip, so I've installed pip. I've pulled the GitHub repo from my account in GitHub. I then installed all the requirements, and then I'm going to manage.py run service. So I'll start the Django application. I'll just walk through the site, give a quick overview of it, and then I'll actually add the observability stuff. So I've pre-built the cluster. I've somewhat cheated by deploying FileBeat for syslogs just so you can see some data, but I'll go through deploying MetricBeat, just take you through that process. And so, this is kind of live, so if it does fail, then you get to see me fail in public. But this is kind of how much faith I have in the whole ecosystem, and that I would put myself at risk here. And then I've deployed something called Heartbeat for uptime monitoring for my application. And then what I'm going to do then is really the heart of it, which is to import our APM library, update the settings.py for my Django app. I'll just run the APM checks. And then if we have time, I'll add security data with our audit beat. So sounds good for everyone. I guess I actually can't, I don't think if there's any questions coming through yet. I think that's for only afterwards. Adam hasn't told me anything about whether or not I need to change tack here. So let's go on with the demo. All right, so this is my site at the moment. It's not able to connect, but I'm still on this virtual machine here. So I'm going to run my command here. I think I should have this saved. I'm not going to tempt fate by typing it out. There we go. So we're running a Django site. This should now resolve. So the premise here is that this is a very simple and basic learning management system. If you were to have like instructional videos, I need to zoom in more. Okay, we'll do that. There we go. Yeah, that should be okay. And I'll also zoom in a bit more on my terminal view. There we go. So terminal's running. We'll actually leave that open. And oh God, yeah. The point of this site is if you've got like instructional videos on YouTube and you wanted to present them in some kind of ring-fenced kind of platform that required a login, you could potentially use this. It's really a simple thing. I've written it so that I can basically put my kids' favorite YouTube videos that we watched 400 million times during lockdown, and we'll continue to watch 400 million times. But these are basically featured videos, and you can go through and watch those videos. I think I'm logged in, so these just pull directly from YouTube. I'll actually log out, so I'll just get some records going with user authentications, and then this would be the catalog of which channels, and able to go through and see the videos for those channels. So it's really straightforward. Okay, and then you can also see like what have you done since the dawn of the site. What is your activity log? So really straightforward, nothing amazing, but it's just a Django app. What we'll do now. Okay. Yeah, right. So I'm just seeing bottom right has my camera. Okay, so I won't put anything bottom right. Okay. Okay, so let's go into our Elastic Cloud environment. So what I want to do now is basically take you through the process of building a cluster. It's really straightforward. You can register on Elastic Cloud for free, provide a business email address, no credit card required. You can basically scale up to, I think your largest node size is 4 gig, and you can probably do three nodes. So on a hot node storage, you probably get enough for like 0.5 terabytes worth of data. So you can, for free over 14 days, play around with a fair amount of data, and you're never going to get to that level unless you're really sending a lot of data. So this is my demo cluster. I built it basically following this create deployment process. So when you create a deployment, you choose which kind of template you want to follow. It's quite useful to go with, the template of the use case that you're gonna go for. But I'll choose the Elasticsearch because that gives me a little bit of more options to play with. So we have a bunch of different options like storage optimized, compute memory. We also have the ability to spin up clusters in different locations so that you can then search across multiple locations. So you can collect data in different regions and then do or you can collect data on different particular clusters with their own specific use cases and search across them. It's dangerous to say different regions because we do have regional limitations around that. So I'll stick with normal. A lot of our clients use hot warm. Basically, that means that you're able to tier your data. So like tier 1 data, like, hot data, stuff that can solve your problems or that you're going to ask like lots and lots of questions for operationally, like right now, today, tomorrow, and maybe the day after. You use hot tiers, and then if you need to keep it, but you're not going to ask it as many questions, you want to keep it for longer, but you don't want to pay for that sort of top tier storage, you can put it on a warm tier. And soon we'll be introducing a cold tier and a frozen tier as well. So that's a great way to optimize your costs. But for this demo, I'll just go for a single storage type. And then the next thing is that you're actually now able to choose your provider. So you can choose GCP, Azure, or AWS. So I'm in my environment's on GCP. So let me just stick with GCP and I'll go to Belgium or Netherlands or wherever. And then I need to zoom in again, yes. So actually this is probably a little bit of an Easter egg. If you choose Belgium, we often roll as like a pilot deployment, the latest version of Elastic into that. So I mentioned earlier in the call, 7.10 was our latest version. So we've actually got 7.11 in Belgium. And if I was to go to Netherlands, Netherlands was on, yeah. It doesn't really matter. So let's look at Frankfurt. Oh, well, we seem to have actually rolled 7.10. Okay. This does sometimes happen where we release a version of Elastic without actually necessarily formally releasing it or announcing it. So that's pretty good news. So let's choose Belgium, and we can 7.11, 7.10 doesn't, it's always good to be on the latest version. If you do have a snapshot of an Elasticsearch cluster in S3 and an S3 bucket, and you've registered that repo with the cloud platform, you can choose to restore from there. There's a couple of more options, but the best thing then to do is to go from there and customize. So like I mentioned, if you're running a 14-day trial, your limit would really be 4 gig, and you can see per host, you can get 120 gig or per node. So it's possible to go up to 3 zones. So these are actual availability zones within that region. So the cloud provider does the underlying segmentation and separation of the nodes in the cluster. We just leverage the different AZs. But you can build your cluster out and you can see what kind of storage you'll get on that node. If this was a warm node, so this is currently a hot node, but if it was warm, you'd get 4 times as much storage. So just in terms of the RAM to storage ratio, we allow much more storage on the warm node, so you get more out of it. Master nodes, so if you're managing your own cluster on-premise, master nodes can be a nightmare to manage. In the cloud, we automatically deploy master nodes based on how many nodes you've actually got holding your data, and then coordinating nodes. If you need to focus on ingestion of data, add coordinating nodes. And if you want to add machine learning capabilities to your cluster, which I'll be happy to take you through, you can add capacity in the machine learning area as well. Kibana, you can deploy across multiple zones. It's completely stateless. So, if you deploy it across 3 zones, we manage the high availability around that. And, don't worry at all about adding additional overhead in terms of 1 zone versus 3 zones, but you can then scale your Kibana deployment. You'll see Kibana only goes up to 8 gigs of RAM. It's an incredibly efficient web application. We don't actually need big hosts. I'm not sure if you can hear noises in the background, but like everyone else, I obviously work from home and families make noises at 6:30 in the evening, so I apologize for that. So I won't actually hit, well, maybe I could, let me just build a cluster so we can go back and see how long it takes to build. So let's leave everything as it is. I'll add a machine learning node as well. 1 gig should be fine. Now we can just create the deployment. I get a an hourly rate, I get my total memory, my total storage, and also don't want to overlook the fact that, unfortunately, I clicked it too late, but there's an equivalent API request with the cloud platform. So yes, you do a lot on the UI, but there's also an API request which gets generated because everything we do on the back end is API based. So if you wanted to define a cluster via JSON as a JSON file, you could also define it as a Terraform template and leverage our Terraform, what's it called, operator or provider. I think we've now got an official Terraform provider. So we give the Elastic username passwords. That's kind of your master password, gets you everything. It's good to keep that, but I'll just continue without downloading it. We go into our clusters, and I've got my demo cluster up running already. So it's pretty small. What's really great is that I have endpoints for Kibana, Elasticsearch, and APM as well. And I can just launch straight into Kibana from here, and I really shouldn't get prompted because it's single sign-on all the way through. So won't spend too much time going through Kibana. I'll just focus on the observability, but just to like give a sense of what Kibana does, it is really the window into the Elastic stack. So if you wanted to do data exploration, understand your indexes, map your indexes, build visualizations, use machine learning tools to understand more about your data, get notified proactively about anomalies in your data, use our geographic mapping tools. It's really, Kibana is probably a 90-minute demo all on its own. So I'm just really going to focus on observability. So you see in this landing area, we have our 3 main solutions, and then our specific Kibana type functions. And then that's kind of reflective of the left-hand side menu here. So if you open up or you click on this hamburger here, you kind of get all the menu options associated with Kibana. These are all part of the basic licenses, no separate licenses, as I mentioned, per each of these capabilities. So I'll go into observability, and now you'll see I was actually somewhat cheating. I did mention it. I've deployed FileBeat, getting syslog files from that particular VM over the last probably 6-7 hours. So you can see I've got logs that are coming in. This is just the observability homepage, but if I wanted to view those logs in more detail and see what am I, get the statistics about my host, I could look at these log files, and I can search these log files with a predictive search capability to understand more about my host log files, for example. So there is some type ahead. So let's see, if I do host.name, it gives me a suggestion for host.name. It tells me what my operators could look like, and then even predicts based on the data what are my options in terms of host names. And I'll simply just enter, and I'll get only logs for that particular host. If I'm looking for highlighted terms, so I think metrics is a good one to highlight. I can type in the term I want to highlight, and it goes through and highlights those terms for me. And I can see along the timeline here where those terms actually come up. So let me remove that, but you can see my log rate over time is reflected on the right-hand side as well. So I can see like what is the flow of logs and which portion am I actually looking at. So that's this little like blue box here that represents these logs that I see at the moment. It's possible to set up anomaly jobs for logs. You can categorize your logs, and then there's also like a settings option for this view. So I could add like a column into this view in particular. But let me go back into observability. And then the first thing I want to do, if I go back to my slides, is I want to, I've done this, I've done that, I've done FileBeat. Now I want to deploy metric beat. Cool. So if I go to Kibana, it says, well, I've got no data to display. So that's fine. Let's add some data. So I click on the add data. Now it gives me some options for beats, and a beat is a very lightweight shipper. It's written in Go, and it collects data from hosts, basically, and applications. And it ships it to Elasticsearch, and then it flattens it into this concept of an Elastic Common Schema, which would really be this slide over here. So different platforms have different field labels, Nginx, Apache, different applications, they all kind of give IP addresses a different name, right, or a different label. So if you haven't like normalized your data to ECS, actually normalizing was the wrong word, standardizing. If you haven't standardized to ECS, the Elastic Common Schema, it's up there, your queries need to cater for all of those different ways to label a source IP. But with ECS, it kind of just standardizes that data. So all of your data, doesn't matter where it comes from, has the same label. And that's done automatically when you use our beats with our specific integrations. So it makes your data a lot more powerful because you have more utility over that data. All right, so I want to get system metrics. So let's just find system metrics. And Kibana now gives me an option basically to install based on my operating system. So let's bring my terminal up. Actually, not one. I need to open a new one. So let's open a new terminal. Don't worry, Adam, this time I will not forget to zoom in. This can take some time. So I will download the package from Elastic for metric beat, and I'll literally just follow the prompts in Kibana, and I'll start to gather metric beat data. So let's paste that in. And I actually have this in my notes on this side. Do I? No. So we will then unpack it. I mean, you know, you don't really need, it's what's great about this, you don't need to know anything about the underlying operating system really to get this enabled. Okay, then we're going to modify our metric beat configuration file because we want to send the data to the right cluster. So I've got my my information here. So you would see that it kind of says, well, add these cloud details to your metric beat .yaml. So I've copied that off of my notepad because I've embedded the password in that. And that's why it's important to save that password somewhere when you build your cluster, because it's really important, or create a specific ingestion user that you can then use to gather this data and send it to Elastic with. And then we'll just enable the system module for metrics. So point of just to note is that metric beat, obviously there's a huge amount of modules, which I kind of, when I was going through that list of different metrics I could get, there was all those metric beat modules that are available. I've got to tell metric beat which one of those I want to use. And now I've got to tell my cluster to set up Elasticsearch for metrics, because currently I don't have a metrics index, and I don't have any dashboards. In certain instances, I don't have machine learning jobs. So, you know, I can't really do much with that metric data. I can, but I've got to go do it myself. When you tell metric beat to set everything up for you, it calls back to the cluster and says, hey, we've got some metrics that we're going to collect. You better get yourself ready for it. So that takes like 1 or 2 minutes, and that's happening live. And I'm seeing we've got 20 minutes left, so I'm really going to rush through the adding of the APM, but I'm hoping that this is all adding value. So we're just waiting for Kibana to load up those dashboards. That should happen fairly quickly. One of the other things is that with metric beat, so if we look at that list, if you're running, so I'm obviously at the moment I'm running just the kind of dev web server, but if I was running Apache, once I've done my initial metric beat setup, and same for file beat, once I've done my initial setup, it's really easy to then add new capabilities. So all you need to do is you need to go into this line that says modules enable Apache, enable Nginx, enable whatever else. And you start to then enable those modules that are inbuilt into metric beat, and it starts to look at the log files for those, and it starts to transform that data, convert it to ECS. It's also doing with the index setup and the dashboard setup, it's actually creating what's called an ingestion pipeline. So it's converting fields, and it's all based on what we know about where this information is coming from. So now it's done. We can start that service. We go back to Kibana. We can check for data. Cool, that's great to see in the demo. That is received. And now we can go to the metrics dashboard. So it's just like a very straightforward walkthrough, telling me, what information I can get and how to get it and which dashboards to go to. So now I'm starting to, you can see I've got my one host registered. I can see my memory for that host, my disk used. I can get figures like inbound and outbound traffic. Anyone who managed to get this IP address, where was it, is more than welcome to start clicking through the site and generating work for that service. So that would be this guy over here. All right, so now this is kind of where I want to go to next, which is I want to see application information for my Django site. So I move into APM. Application Performance Management is really like I wouldn't say it's a cherry on the top, but it really pulls things together, right? So it really pulls things like logs and metrics together. I have no data for APM yet. Straightforward, let's go add some data. So this is going to require a little bit more of let's call it typing and like finger trouble. So I'm going to rely on copy and paste here. But let's pip install the Elastic APM. All right, so I didn't get that. So let's just grab that, go back to my application. I think let's do it in this view so I can stop. I can stop my Django app. I can install Elastic APM in my virtual environment. Downloads and installs, and now I've got this agent configuration that gets done directly in my settings file. So let's open up my settings file. Right, so that's my settings file, and I'm going to add all these Elastic APM attributes. So the first thing we're going to do is we're going to add Elastic APM. So this installed application. So I'm going to go to my installed apps dictionary or list and put Elastic APM Django in. And then I'm actually going to put this whole new definition in for Elastic APM right at the bottom of my file. Just after crispy forms. So we'll put Elastic APM's demo information there. So Elastic APM service name. So this is Django Live Demo. This is my token, and this is the server URL. So this is my Elasticsearch URL. And very importantly, debug needs to be true. Why is that looking a little bit different? There we go. All right. So let's just check. And then we want to add to middleware, we want to add for sending our performance metrics, we want to add Elastic APM to our middleware settings as well. Okay, there we go. Okay, now we should be good to go. So we'll modify, yes. I think I glanced over debug equals true. This is obviously not a production site. So by default, it won't collect for a dev site. Just set debug to true in the actual APM settings, and you should be good to go. Let me not forget to run my application. Where am I now? Okay, what is this? There we go. Let's see, that's a problem. Okay, obviously there's the same issue as with my debug, no problem. So let's just fix the service name. I guess that's because I wrote that in Apple's Notepad. There we go. Let's call this service something a little bit more inventive, like I hope this works. Okay. Okay, that's what you'd like to see. Go back here, refresh my site. Nothing's broken. Catalogs are working. Best of 3D Bot Maker. Great YouTube channel where they race die-cast cars down a track. It's very simple but highly entertaining. And there's even some dramatic storylines that go with it. So highly recommend it. So I'm just generating some traffic here. Just bear with me. Let's log that out. Okay, so we've done that. So let's load our Kibana objects. As you can see, I've cheated because I previously did load something. So I'm just overriding it. Let's launch APN. We should have data coming through with my service name. And there we go. I hope this works as live. And now, before I jump into that service, I can also look at my service map. So imagine I had multiple services all talking to each other. I would have, I hope this works, and I would have a rock solid backend, and I would have whatever other application, all showing on a live service map. And they would all show how they connect together, which is really useful because you can see what the effect of a downtime or poor performance on one application looks like on another application. You can see if I go into this, I can now look at average transaction durations, number of requests per minute, error rates, time spent by span type. So what it's already done without me actually having to go in and manually instrument any of this code beyond the settings file is it's going to find what my main transactions are within the Django framework, and it's giving me time to render for all of those. So if we look at like a static content service, you can see the transaction duration, the number of requests per minute, and also my distribution. So at the moment, I'm sitting at like 1,000 milliseconds. Most transactions look like they're 1,000 milliseconds, one does. And then there's a distribution of transactions across longer time frames. And I can compare what those look like. So I can compare this as like a highly, obviously a normal transaction time span. This is a bit slower, what's different, where was I waiting, that sort of stuff. If I had other services, like multiple services that I've deployed here, I can view the full trace. So then I can view this transaction, not only the internal calls within my service, but also the calls to the other service, because it spans them all together into a single kind of transactional trace view. So I can see how my user journey basically goes through all the services that have been written on the back end. And I can build a picture of what it really feels like to use my application. And also gives me key clues and key information about where to go to troubleshoot and to find issues. I see no one's necessarily clicking around on this. It's most likely because I'm not sharing this IP address, and it's not easy to see. But I'll just do a little bit more clicking so we can see the information actually coming through. So if I refresh this, you'll see there should be exactly that. So new transactions that have come through. Oh, that's quite nice. I see people actually seem to be hitting it, and I've got more information coming through here, which is very, very useful. Right, so if I go back onto my overview page, if I wanted to look at my environment at a glance, I can see, well, I've got a log rate of, at some point it was like 48 messages a minute. And these are the two different collection mechanisms that I'm getting from. I can look at the metrics of my host or multiple hosts, and I can see the number of transactions per minute. Let me paste this in just so that people can go and hit this. It's not going to live for much longer because I'm very cheap, so it won't live for much longer after the session. So feel free to click around. Yeah, where was I? So you can see your number of transactions coming through, and the other thing that I've done is that I've deployed uptime. So uptime is really useful. It's a beat, just like metric beat and file beat, but it looks externally and it says, I'm just going to go and check, like on a ping using ICMP, is the service available? Is it not? And what it does these days is it can actually get a certificate, like a TLS certificate. So when you obviously one of the normally some of the most embarrassing outages are when certificates expire. Without having to configure anything, I know, for example, that LinkedIn's certificate is expiring in 2 months. So if it was my application, I'd have some kind of alert saying, at like 2 weeks to expire, raise an alert, send information to, or send a notification to someone, and they can go and renew the certificate. I've also got my actual Django site, which I've added to the beat. So you can see it was down, but in the recent, like last half an hour, because of I've stood up my application, I can see everything's up now. Alerts are contextual. So within this uptime view, for example, I've just spoken about the alerting. You can create an alert. So you can choose a monitor status alert or a TLS certificate alert. And at the same time, like when you're looking at metrics, for example, if I was to say, hey, I want to create an alert here for my metrics, it will give me contextual information for this metric. So I'm looking, for example, in this view at my host, and I've arranged or I've used the metric CPU usage to kind of give me if I had, let's say, for example, I had 100 hosts, and I said, use CPU usage, it would show a different gradient of blue based on the amount of CPU usage being consumed by that host. So when I say create an alert, I can create a static alert, which says when a host CPU is above a particular percentage for the last minute, do something, right? So send something to ServiceNow, send something to Slack or Jira or PagerDuty. Now that's a static baseline, but you can also create not a dynamic baseline, but an anomaly detection based alert. So I'm not going to be able to go into this today, but we use machine learning to build a picture of what's normal versus what is anomalous and should be alerted on. So we build the normal traffic patterns, CPU usage, memory usage, transaction duration. We build a picture of the application over time. We build upper and lower bounds, and when we have anomalies that exceed those bounds by a significant percentage, we can alert teams, users, create incidents in systems. It's very, very intuitive, and it's very proactive. So there's a huge amount that you can learn from doing that, and I'm not going to have time to meet my kind of bonus here, but I was going to add security data with Audit Beat. I just, in the next 7 minutes, haven't got time to do that. But hopefully, if I go back to my overview, hopefully this gives the members of GPUG like just a quick rundown of what's really possible using basic license feature levels within Elasticsearch, and like I said, using the cloud gives you a really fast on-ramp. I'm having a look at the questions. Yeah, I love this question, and I'm sorry that I didn't answer it earlier. It's pros of cons of Elastic Cloud versus self-hosted. I mean, I'm gonna say one is free, which is self-hosted if you're using basic license, but nothing really is free because it's either time or money. Elastic Cloud is not expensive. We will have Elastic Cloud in South Africa within the next, I would say, 6 to 9 months, most likely earlier. We have a huge demand for it. It's not, doesn't require a huge investment. It's fully automated. So many things are taken care of for you. If you've ever done the Elastic Certified Engineer course, so much of that is around cluster management, Elasticsearch.yaml. It's Elasticsearch once it's going is really, it's pretty simple and robust. But typical things that you would just need to do with your own environment on-prem are fully taken care of with the cloud. So I would always opt for cloud, especially if you are paying, if you like a customer who has production applications that need Elasticsearch observability or search solutions. Cloud is always first prize. So do we sanitize log? Well, so we have, and you can create as complex an ingestion pipeline as you would like, which means that you could let's say you wanted to use Logstash you wanted to get beats to collect the log, and they can sanitize logs, right? So they can actually drop fields, they can combine fields. There's a lot of mutation that can occur. You've got to configure it, but it's totally able to do it. What I would recommend would be a proper ingestion pipeline. So use the beats to do the basic, because that's on your host. Send it to Logstash. Logstash is also super light, but you need to run it on a separate virtual machine in like a best practice scenario, and it scales extremely well, and it's really efficient in what it can do. And use the Logstash to filter your logs, add fields, drop fields, enrich your fields. Look up. We have a lot of clients that use Logstash to look up information in a SQL database and enrich the log as it comes through. And like if you're talking about sanitizing, it can do that as well. And if anything crashes, right? So let's say Elasticsearch crashes or your source environment crashes. I mean, you're not going to get logs coming from it then, but you would have had the last logs that might give you a clue as to why it crashed. But let's say you're running Logstash and your cluster crashes, say it's self-hosted. Logstash has a bigger buffer than a beat does. So if we have clients that are doing 100,000, 250,000 events a second, and it's like no issue for Logstash. Obviously, those buffers get filled very quickly, so it's much better to use Logstash, or I would say maybe Kafka. Apache Kafka is also fairly powerful, but Logstash is still really good for this use case. All right, the best way to learn about this, again, I love these questions because it's really, really simple to learn about Elasticsearch for free. So we have docs. Okay, the docs are some of the best docs I've come across, if not the best, in my time. That would be this elastic.co guide. You've got stack documentation. So if you want to really get under the hood, Elasticsearch, how to query Elasticsearch, cloud documentation, whatever you really want to, understand, the documents are really, really strong. But you could rabbit hole the docs properly, right? So let me paste the URL. I really believe in learn.elastic.co. So if you, by the way, sign up for a 14-day trial on cloud.elastic.co, you immediately get access to learn.elastic.co because it's federated authentication between the two platforms. You're probably going to see some stuff that is more Elastic internal employee access stuff. So that's only at the bottom, so don't worry about that. We've got some free quick starts. Quick starts are great. Okay, so really like the quick starts, we've got a specific URL for this as well. So let me send it to Adam. So you can learn about logging metrics, APM, workplace search, app search, Elastic security as well. So all of these are free and they're quick. We've got virtual classes. Some of them are also free, actually. Let's not go there. Let's rather look at the catalog. So some of those virtual classes are on demand, and some of those on-demand classes are free. If it's a facilitated virtual classroom, that's not free. That's that's people's time in terms of actually being live on a Strigo training session, walking you through basically that course, and then you also have a lab, and it's a lot more structured. Whereas on-demand tends to be, if you've ever done AWS Cloud Practitioner, very, very similar. It's the same AWS type of, I think whatever system they're using, we're using it as well for our on-demand stuff. So it's that kind of scroll, watch a video, look at the text. A lot of those are free, specifically with COVID. Obviously locking the world down, we made a lot more courses free. So I would really recommend. And then if you really want to, depending on what your end goals are, we have paid for training, like the certified engineer course, which is broken up into two, engineer 1 and 2, certified analyst courses. And now we have a certified observability engineer course. Now, these two courses on their own, like the analyst and engineer, very, very useful. If you're in operations and if you want to understand more about how to troubleshoot issues in your environment, this one pulls it all together, which is, I've just recently finished this. It's brand new and it's really powerful. So that's a very long answer to a fairly short question, but there's so much stuff here. It's kind of, it's a bit ridiculous actually to see how much training material we've got. And I would say that the certification is well respected. It's not an easy exam. It's like a 3-hour practical for both, for engineer, and then Kibana analyst, I think, is a 2-hour exam, but they're not easy to get, so they are well regarded. All right, I think let's see where we are. So yeah, this is pretty much it. Let me do one thing and just show you how in the security application, so I didn't go into security at all, but I wanted to just stress a point that the data is actually there. So even though, let's say you don't have any security analysts on your team, or maybe even in your organization, and you wanted to understand more about the security posture of your environment, you'll see that we have events coming through already because we use these system log files in our security application or our SIM. It's very easy to then take those log files. I've got audit beat data, which I actually deployed on a different VM, but adding audit beats is really straightforward. You just add data, you look for the security module and audit beat, that one, you follow the same steps, and you can then start to really drive a lot of security insights into your application. I'm going to leave it there just on that last note that it's really simple to add data to Elasticsearch. And if you're concerned about things like, well, how much data really is this? Like how much space could this potentially take up? We can have a look at index management. My biggest index is 20 meg, and that's 4 metric beats, and that's been running about a day and a half. So really, these are not large data footprints at all. And on that note, so I'm just going to check the questions. No more questions. I'm really grateful for the time. Let me end this professionally with a slide. So I'm grateful for your time, and it's really been fun presenting. And please reach out to me at my mail address on LinkedIn, or just go to elastic.co, and you'll manage it. You'll find a way to get information and get put in touch with someone who can help you. So thanks so much. Thanks, Adam, and everyone at GPUG.
All right, thank you very much, Tim. I hope everyone enjoyed the talk. I think even though it was only one talk, it was a very interesting talk, certainly relevant to me. So I might be trying out some of that stuff. We are always interested in speakers. So if you are interested or even want to are a first-time speaker, you can reach out to us. You can reach out to myself or Hussein or Angelique. They're actually in Discord now. Angelique, one of the organizers as well, is Lama Mama or something along those lines. Interesting, but I'm just by my name, Adam Piskorski. So I think that will be it for tonight. We will also be looking at trying more interactive online meetups like our Code Carters. We'll see how that goes, because we are really hoping to have in-person meetups sooner than now. So we apologize for the big gaps between meetups. And yeah, on behalf of the conference organizers and everyone at GPUG, I think thank you guys for coming, and good night.